Here topic is thermal dependence of resistance. The basic formula that we are using, R at T degree Celsius equals to R at 0 degree Celsius 1 plus alpha at multiply T. Here alpha at any time in our syllabus alpha is a constant. We can use this formula also sometime. R final equals to R initial 1 plus alpha delta T. If delta T is very less, and from here we can also say alpha is R final minus R initial over R initial delta T, and from here alpha comes out to be R1 R2 minus R1 over R1 T2 minus R2 T1. So these are the basic formula we have to use. Now looking into the given question. This is a question asked in the previous year IIT 1980. What is the formula? What is the question? Question is at 300 Kelvin resistance is given. We have to find temperature when resistance becomes 2 times alpha is given. So we have general formula R at T degree Celsius, R at 0 degree Celsius 1 plus alpha into 2. So its initial resistance is 1 ohm, 0 degree Celsius not given generally, and alpha and temperature always used in degree Celsius. So 300 Kelvin is 27 degree Celsius. In the final conditions, resistance comes out to be 2 ohm, 0 degree Celsius resistance not given, and temperature is done. So dividing this term can say only unknown is the T. So we can calculate T. What is T? Here after solving R naught delta T, we get cancel. So 1 by 2 D equals to 1 plus 27 alpha 1 plus T alpha. So cross multiplying T alpha equals to 2 plus 54 alpha. So T minus 54 equals to 1 over alpha. Putting value alpha we get 800. So T comes out to be 854 degrees Celsius. So by adding 273 we can get the value in degree Kelvin, in Kelvin. So that comes out to be 1127 Kelvin. So this is our required answer. Same initial conditions are given. Resistance is R naught 0 not given, 1 plus alpha into temperature is 15, and final condition resistance is 3.29 ohm, R0 not given, 1 plus alpha, temperature is at T. So dividing only unknown is alpha, so we can calculate alpha. Here there are two wires, two conductors having same resistance connected in series. So R equivalent initial R equivalent is 2R0. What will be the resistance after rise of the temperature T degree Celsius? So R0 comes out to be R0 1 plus alpha 1 T, and this comes out to be R0 1 plus alpha 2 T, and finally what is R equivalent? R equivalent is R0 1 plus alpha 1 T, R0 1 plus alpha 2 T. So initially R equals to 2R0, and finally equivalent equals to 2R0, R0 alpha 1 T, R0 alpha 2 T, and this final is also, we know this final is also initial into 1 plus alpha equivalent into T. 2R0 gets cancelled. 2R0 gets cancelled. So R naught taking common alpha 1 plus alpha 2, that comes out to be 2 R naught alpha equivalent into T. So R naught gets cancelled, T gets cancelled, here alpha equivalent into 2 R naught 1 plus alpha into T. T gets cancelled, so what is alpha equivalent? Alpha equivalent is alpha 1 plus alpha 2 by 2. In similar manner for series, this also comes out to be alpha 1 plus alpha 2 over 2. Here this is a previous year JEE question, AIEEE 2009, and we have to find alpha. Conditions are given. This formula tells that we have to use formula R final equals to R initial 1 plus alpha delta T. So what will be alpha? Alpha is R final minus R initial delta T. So that comes out to be 150 minus 100 divided by 100, and delta T is what? 200. So that comes out to be 1, that is equals to 2.5 10 ka power minus. So the statement is correct. But R final equals to R initial 1 plus alpha delta T formula is useful only if delta T is very small and difference of the R must be very less than the R initial. So all conditions are given. So both the statements are true. Here same condition, initial conditions given, 40 R naught not given, 1 plus alpha, temperature is 30. So finally resistance is 94.6, R naught not given, 1 plus alpha, temperature is up. Here alpha is given, so we can calculate the T accordingly. Similar questions are given here. Let's see AIEEE 2006 question. Here initial conditions are given, 100 ohm, that equals to R naught 0, 1 plus alpha, temperature is 100, and we have to find final resistances are given, that is R naught 0 degree Celsius, 1 plus alpha, and temperature is unknown. So by dividing and putting the value of alpha here, we get the temperature accordingly. Thanks.